You're listening to the Cyberwire Network, powered by N2K.
Hello, everyone, and welcome to the Cyberwire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
YAML files are Kubernetes' way of doing everything from configuring stuff to creating pods to everything else. While it parses some parameters in this YAML file, there may be some parameters who are unsanitized and may lead to command injection opportunities and to command execution from the Kubernetes from the Kubernetes service on the node or on the pod or on the cluster itself.
That's Tomer Peled, a security and vulnerability researcher at Akamai. The research we're discussing today is titled What a Cluster? Local Volumes Vulnerability in Kubernetes.
A few months back, we put up a blog about another CV, which led to a system RC over every Windows node on the cluster. On the tail end of that research, we found out another CMD command execution that could lead to a command injection. And this research is the culmination of all of this research that we've done since the last CV. Sorry.
Yeah. Well, let's dig into it here. But before we do, though, can you give us a little bit of the background for folks who might not be all that familiar with Kubernetes? What do they need to know going into today's explanation of your research?
So Kubernetes is container orchestration framework. It's being used by a lot of developers. And today, we are going to talk about command injection in its parsing mechanism. So YAML files are Kubernetes' way of doing everything from configuring stuff to creating pods to everything else. While it parses some parameters in this YAML file, there may be some parameters who are unsanitized and may lead to command injection opportunities and to command execution from Kubernetes service on the node or on the pod or on the cluster itself.
When we're talking about sanitization here, what exactly do we mean?
Sanitization, in a broad sense, is when an application tries to find out if there is anything malicious going on while parsing a command. In this sense, in Kubernetes, sanitization means that every parameter in a YAML file is going to be checked to see if anything malicious is going into the cluster, while creating a pod, while creating a configuration, while creating a secret. So every time one of these operations is being executed, it needs to be sanitized. We found out that it's not actually the case, and in some cases it will lead to an RC, which is a remote code execution over Windows nodes on the cluster.
Well, digging into some of the specifics of the research here, you start out talking about Kubernetes volumes and point out that it's important for people to understand what we're talking about there. Can you explain that for us?
Yeah, sure. So Kubernetes volumes are the way that Kubernetes facilitates the share of data between a pod and another computer, another node itself, or another host, or from the host to the pod. So, for example, you can take a Git repository and the pod itself, and a Git volume will actually link between the repository and the pod.
Let's dig into the vulnerability itself here. What's going on?
Okay, so in this vulnerability, a parameter inside the local volume feature, which is one of the volumes that you can create, that you can use. Local volumes, if we can just talk a little bit about what local volumes are a way to share a drive, not a folder or a Git repository, just a drive between the host and the pod itself. So if you want to share your D drive or Z drive or any other drive, you would use local volumes. So this vulnerability occurs when the kubelet service on a Windows node tries to symlink between the drive and the pod. It will actually try to execute a command, and we can, as an attacker, use it to inject. Instead of a drive letter, we can inject anything we want, and it will be executed on the pod or on the node.
Oh, wow, that's interesting. So, what's going on in your estimation that leads to this functionality? I mean, is this purely an error that it shouldn't be looking at this as code?
Oh, sure. So Kubernetes itself actually has the problem in it, not Windows. It will try to run a CMD command. The CMD command will try to symlink between a drive and a pod location. The pod location it will take from itself in the creation process, and the drive letter is something that you can customize as a user. So actually, it will happen from as an attacker, we will be able to do it from a parameter standpoint. And what happens is that Kubernetes will not check for anything while creating this volume. So you can enter anything you want in the drive letter or in the path parameter, and it will just take it into the CMD. And what you can do with that is that while CMD is running, it can concatenate between several commands. When you do an end-to-end command, it will actually try to run this command before trying to do the actual command itself, the actual symlink.
And now, a word from our sponsor, Zscaler, the leader in cloud security. Cyber attackers are using AI in creative ways to compromise users and breach organizations. In a security landscape where you must fight AI with AI, the best AI protection comes from having the best data. Zscaler has extended its zero-trust architecture with powerful AI engines that are trained and tuned by 500 trillion daily signals. Learn more about Zscaler Zero Trust Plus AI to prevent ransomware and AI attacks. Experience your world secured. Visit zscaler.com/zerotrustai. So what is to be done here? How can folks protect themselves against this?
Okay, so there are a few ways to mitigate this vulnerability. One of them is of course, the main one is to patch your cluster to a version higher than 1.28.4. Another way to do this, to try and mitigate or block this kind of vulnerability, is by using an OPA rule, which OPA is an Open Policy Agent. And another way is to use RBAC or RBAC, role-based access control. And with RBAC, you will be able to determine which user can do which actions, and we will be able to more granularly control what it will be able to do and what you can see. So you want to be able to do a local volume attachment or symlink. On the OPA side, you will be able to see what's going inside the cluster and what's being created. So we'll be able to block it from that end. But majorly, patching to a higher version is going to be your main course of action.
One of the things you point out in the conclusion in your research here is you say this is a great example of why the shared responsibility model is crucial in security. Can you explain that for us?
Sure. So security administrator needs to be alert for everything that's going on in the cluster or in Kubernetes itself, and they can take outside precautions to help avoid a serious security impact on their organizations.
Our thanks to Tomer Peled from Akamai for joining us. The research is titled What a Cluster? Local Volumes Vulnerability in Kubernetes. We'll have a link in the show notes. Don't struggle to align your organization's cybersecurity with business risk. Get the only solution that goes beyond reacting to threats with vulnerability and risk monitoring. You need the next evolution of MDR, and only Critical Start delivers it. Critical Start doesn't just monitor and respond to threats. They put you in control by detecting suspicious activities, quickly responding to contain threats, and identifying your most critical assets and protecting them against vulnerabilities and exposures. With continuous visibility, expert guidance, and measurable risk reduction, Critical Start has redefined what it means to manage cyber risk. Demonstrate provable security maturity to your leadership while positioning your program to achieve the greatest risk reduction per dollar spent. Stop fearing risk and start managing it with Critical Start. Visit criticalstart.com and request a demo today. That's criticalstart.com. The CyberWire Research Saturday podcast is a production of N2K Networks, proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. This episode was produced by Liz Irvin and senior producer Jennifer Iben. Our mixer is Elliot Peltzman, our executive editor is Peter Kilpie, and I'm Dave Bittner. Thanks for listening.